So today we're going to look at how to multiply two different polynomials. So I want you to take a look at this first problem, and you might think about a similar problem like 6 times 27. Now, when you learned how to do multiplication, you may have used a break apart strategy to think about this as 6 times 20 and 6 times 7. And then you'd combine those two things to get your result. Now, you can actually combine these because they're both numbers. So we can use a similar model and a similar strategy to multiply 6 times 2x and negative 7. So if I take 6 times 2x, that's going to give me 12x. And 6 times negative 7 gives me negative 42. Now, I would try to combine these, but I can't because they're not like terms. One's an x value, one's a variable, and one is a number. So we'd leave it like that. You might see this in algebra as just referred to as the distributive property. So I'm going to multiply those two quantities. Even if I don't have a number, I have a variable, I can still apply this same process. So if we think about negative 2x multiplied by 3x squared, well, negative 2x times 3, now x squared is really x times x. So I could multiply these whole numbers, get negative 6, and then x times x times x gives me x to the third. So in this box, I've got negative 6x to the third. And then I could take that negative 2x and multiply it by the 5 and get negative 10x. Now, these are both x's, but they're not like terms because one x to the third and one is an x to the first power. So we can't combine those, so we'll just leave that expression like that. Again, we could use the distributive property, thinking about it from an algebraic lens, and just making sure you're really cautious to distribute and look at all those signs. So here we have one that's a triple distribution. We're taking one number, or a monomial, and multiplying it by a 3-term, or a trinomial. So I'm going to get 15x to the third. 3 times 2, 6, x times x, x squared, and then 3 times negative 7, negative 21x. So I'm going to get 15x to the third plus 6x squared minus 21x. Similar idea, I could use the distributive property to get me the same thing.